Okay, good morning, everybody. I think we're going to begin here. My name is Peggy Meehan, and I'm with Visa Lighting. I have a couple of housekeeping, cleaning things to take care of first. First off, any AIA, RA credits that you would like to sign up for, at the end of the program, there will be a list outside. Please sign up with your AIA number, and LEDucation, DLF will submit everything for you, so you will get your credits. Second, we have a docent program that will be starting at the end of this program. At the end of the question and answer period, I will come in and break everybody out in groups. So at the conclusion of the presentation, following the question and answer, as I did mention, if you are interested in staying after for the docent program is small groups from individuals within the lighting industry. We will break up in small groups. The docent, the tour will begin 6 to 8 people per group. They will take you around to very specific manufacturers just to give you an introduction to lighting and manufacturers. And if you have any questions or answers, they will be able to help you. It will be private individuals tours on the docent tour. If you're interested in that, they will be held immediately after the presentation is given. Next, I'd like to present a plaque for Deborah for taking the time and the energy. And before you speak, because do the question and answer, then we have to move on to the docent tour, and then we have another presentation afterward. I do apologize that it does seem a little backwards that we're doing it prior to the presentation. Thank you very much for traveling here.
You're 1 second.
I do appreciate it.
I'm gone now.
Thank you. If you'd like. Oops.
Very nice.
Oh, it is lovely. Thank you. Okay, next, Deborah Gottsman is the principal of Gottsman Associates, an award-winning architectural lighting design firm established in 1999 with distinctive expertise in sustainability and heritage applications. Deborah's 25-plus years in all facets of the lighting industry, including design, engineering, management, education, and manufacturing, gives her a unique contextual understanding of lighting from all perspectives. Deborah has successfully worked on projects in many sectors and has taught lighting at all levels to a wide audience from students to senior architects. A past president of the Toronto section IES, Deborah has been involved in the IES-NA at local, regional, and international levels and has awarded the Toronto section Service Award in 2013. Deborah?
Thank you. I have a couple of housekeeping items. There is supposed to be a fill-in sheet that you were supposed to bring, but I believe they've printed them. They just haven't arrived yet, so you might be receiving them midway through the presentation. And given that I'm Canadian, I do spell color a little bit differently, so it's not a typo. My mother is a fantastic cook. Growing up as a kid, we were a foodie family, and I particularly enjoyed her brisket, so I was always paying attention when she was making her brisket. So she would take the slab of meat out, and she would season it up, and then she would, slice off that tip at the end and put it in the pan and bake it up and serve it up, and we'd all be really happy and licking our lips through dinner. Fast forward a number of years later, my husband and I are now the ones making the brisket. And my mother happens to be over one day, and she's watching me, and I'm seasoning up my brisket, and I take a slice off the end of it. She looks at me, and she says, "What are you doing?" I said, "I'm doing exactly what you did. You always, I thought, squared off your brisket." She said, "Honey, I have a really small pan. You have a much bigger pan. You don't need to be cutting off the end of your brisket." We develop habits and processes because they're needed usually, but at some point we may find ourselves cooking in a different pan. And that's where we are now in the lighting industry. LEDs have changed the paradigm of our businesses. And we, being architects, lighting consultants, manufacturers, agents, whoever, we have to reconstruct our approach to suit. And that's what I'm here to tell you about today. So first, imagine that you could design anything at all that you want with light. You can take your picture and put it on a wall in light. You can make a rhinoceros. You can have any color you want. And imagine you can design absolutely anything, and then you can actually have it built. Because we all know that we often design things that don't get built for one reason or another. Sorry, I've just lost my mouse. Bear with me.
Oh, it's okay. Two screens. Two screens.
Okay. I'm going to have to forget that. So, I mean, these are the learning objectives. You've probably seen them. But basically, what this seminar is going to do today is we're going to review very briefly, I hope, how we used to deal with various aspects with legacy technology, and then we're going to get into LEDs and take a look at how things have changed and how they affect all of us. Now, usually at this point I say, don't worry if it gets too technical and we go over things too quickly, because at the end of each section, I'm going to guide you through these fill-in sheets that will help you summarize the key points. So at some point we will get those, but I will still summarize, okay? Now this is a pretty jam-packed hour, and I've got to be on time. So if you have burning questions, please go ahead and ask them. Otherwise, if you can keep them to the end, just to keep our flow going. So let's take a look at our old pan. So first we're going to talk about color fidelity, and I'm definitely not going to get into this, color rendering index. This was the way, and we still do use it sometimes. We used 8 color samples, and we basically had one number. Now, it wasn't perfect, we all know that, but it was pretty easy to work with. Then if we wanted to ensure that we had good color out of a fixture, it had really not very much to do with the fixture, but it had everything to do with the lamp. Lamp is what gave us our color. And regardless of what we may think of a 41K, 80 CRI, T8 lamp, with a little experience, if we would say a T8 lamp, 41K, blah, 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 we'd have some idea of what that meant. How many lamp manufacturers were there once upon a time? So I would argue there were three majors. We could push it to 5 with U and V. And how did we achieve color consistency across a project? In the spec, we would say, all lamps shall be by one manufacturer. And that's as good as we could get, and it was good enough, at least then. So the fill-in, for the sheets you don't have, is that CRI is flawed, but easy to use. And there are a few lamp suppliers in the past with similar products. In fact, I used to be comfortable. There were 2 in particular I felt comfortable I could match up pretty easily. Now, lamp life. It's very strange. I have no control of my mouse here. So lamp life was determined when half of a test sample of lamps were extinguished. And it was pretty obvious. Lamps actually used to burn out. And because of that, there were 2 things that we would do as designers. One is we would recommend that at 80% of lamp life, they would do a group relamping. And the other thing that we would do is we'd use a light loss factor in our calculations, right? Depending on the light source, eventually got good enough that when we'd use fluorescent, we could use 0.9. But with some light sources, it was 0.8, 0.7 even. So we were over-designing initially to make sure that we would always have the right light levels. So the fill-in for lamp life is that lamp life was predictable and finite. Now, when it came to fixture options, two very common fixture types were the troffer and then the downlight wall washer. So, in the past, most of these fixtures were constructed in a similar way. I'm not going to say identical. It was bending of metals, it was paint finishes, there might be louvers and lenses. But in many cases, the performance of the fixture, particularly when it came to downlights and wall washers, the performance came from the lamp. Now, when it came to custom and modification, that was not so easy. We could do it, but it was costly, and we were also very limited by the lamp form, right? We couldn't go much smaller than, the profile of a T8. So the fill-in for options under legacy technology is that performance of many luminaires depended on the lamp, and it was possible pretty easily, for the most part, not saying always, but for the most part, to create a 3-name specification. And luminaire form was limited by the size of the lamp. Now, when it came to lighting controls with legacy technology, we all know that they were hardwired. And we went through a lot of growing pains with things like understanding that we really have to commission these control systems. We can't just specify them and walk away. And there were also, remember, the false tripping with sensors and whatnot, and we've overcome some of that. But that's what we were dealing with. But the real stumbling block, at least in my experience over the past few decades, was that in order to implement controls, you had to also get into the specs of the fixtures, because you had to have dimmable control gear. And often, the dimmable control gear could double the cost of a fixture. And so lighting controls were costly, and they were often cut at value engineering phases or cut before they were implemented. So the fill-in for controls was that lighting controls were costly to implement, and dimmable control gear were extra. And systems were hardwired. Now we've got the design process. So with legacy technology, our design process started with the lighting concept, and that's where we would take care of, all of these elements, the task, the hierarchy, what do we want to see, etc. Then we'd get to the construction drawing phase, and that's where we actually make it buildable, hopefully. That's where we take all that information, we prepare our drawings and our specs, and even though it's a small list, we have to take care of a lot there. And then finally, contract admin, and what we're doing there is ensuring compliance with our specifications, and we're doing our aiming and our setup and our commissioning. And the process looked something like this, and we'd spend about 2/3 of our time pretty well in the construction docks, and that's where we had it. Now, the structure of the project looks something like this. You have an owner who always has people to answer to, right? There are other stakeholders, shareholders perhaps, there's the public. And then they hire a design team, the architect, the interior designer, and we become part of that team in some way. And we work fairly closely with the manufacturers and their agents. And that is shown there as a dotted line because we all need to be very clear. These guys don't owe us anything. I mean, they want to sell their product, but there is no contractual obligation there. But that relationship, at least in our business, we find it's a very, very important relationship. Then you want to get the project built, and so, again, the owner hires their general contractor, and they hire the electrical contractor, and the electrical contractor goes out and tries to deal with those manufacturers to actually procure what we have specified, okay? And I want to spend a little bit of time more on that part of the process. So let's think about the tender period. So on a substantial size project, we'll spend, say, a year and a half getting the design together, coordinating all those details. And then we take this massive package of drawings and specifications, and we give it to the contractors, and we say, okay, electricians, I got 3 names for everything. I got some performance specs in here. You have 4 weeks. Make it work. Make it cheap and make it work. Okay, go do it. So the electrical contractor sits there and he says, okay, I got all these electrical distributors that I can work with. And why do I have the number signs there? This is not facetious. Okay? Electrical distributors are the bank. They are the ones that finance our projects. And it's going to depend on which distributor is going to be able to give the contractor the terms for that project. So A might have been good for yesterday, but if you've used up all your credit with them, then you've got to figure out someone else to deal with for this project. So what ends up happening is the contractor is faced with something like this. All these names in the specs and not sure how much they can buy from which, through which distributor. And it can get very complicated. Now then, sometimes it would get easier for us because our equal fairy would come in and we'd say, you can have A, B, or equal. And then the contractors could scurry and make up their own packages and even without that, didn't you find we'd often get substitutions? We often weren't happy with them. Would come after the fact. I've rejected shop drawings and seen the fixtures show up. Oh, I don't know how that happened. Anyway, so this is the kind of thing that would happen. A little bit frustrating for us as designers. We work really hard on this, but everybody has a job to do. And these were kind of the rules of the game. So the fill-in for process is that or equal was commonly used and accepted in specifications. So now let's take a look at our new pen and LED technology. So my associate Sharon, who's in the audience, who I won't embarrass completely, she's also a color consultant. And I said, Sharon, can you tell me all the terms that you know for describing color? Okay? We're going to stand here and read all these now. But, okay, so we know that color is complicated. And so the IES has come up with TM30, right? And now we define color a little bit differently. We take more time, we take more color samples, and we have what's called now a fidelity index. And I'm not going to go into this, but it's no longer a 1-number CRI. We get an RF. And it's somewhere between 0 and 100. And higher is better, but not necessarily, because it also depends on our gamut index, which talks about the saturation and the oversaturation or undersaturation of the color. And then we're also provided with vector graphics that can show us graphically where the light source now sits, right? And so we can have saturated tomatoes or regular tomatoes or undersaturated tomatoes. We can do the same thing with our interiors. And I'm not saying one is right or wrong. I'm just saying we have all of these options today. That's before we even talk about warm, dim, and tunable white. But today we can even prescribe what color we want white to be. So how many LED chip suppliers are there? More than 3? Like maybe more than 3,000 for all we know. I mean, everybody's making chips. And the big guys make wonderful chips, and they also make not so good chips. So when I ask, well, who makes your chips for your fixture, it's almost an irrelevant question because it doesn't matter. It could be anything. So there's all kinds of, and they differ greatly in terms of how you can dim them and how they're aimed and how they're how they've added their phosphor. I mean, there is no one way to do things anymore. So there's many sources of LEDs, and it's difficult to obtain color consistency across the project, right? It's no longer all lamps by one manufacturer. You can't do that anymore. So the fill-ins here for color would be that color metrics are more accurate, but they're more complex. And they also don't necessarily, give us the guidance we need, frankly, to make a selection. sometimes we really need to do those mock-ups. In fact, we're doing more and more mock-ups and samples to talk about color consistency. There's also many suppliers, so we have to work harder to obtain color consistency across a project. And we can now even prescribe what color we want our white light to be. So let's look at our LED options. So these were our legacy troffers, right? So would you kind of agree that this might be today's troffer, the linear? We're using those a lot, and that's like our common, it's almost like our go-to. We don't use a 2x4 or a 1x4 anymore. It would be something like this. And you can see those are nice and linear, but they can also be square, and they can be on walls. And they don't even have to join at 90 degrees. They can also be curved and on different radii. So we have unprecedented freedom in design today, and we're going to see that over and over, even with our new troffer. So how do you put or equal on something like that? Let's take a look at a case study with options. So we were working on a residential project, and we'll be calling this a multi-unit residential. And we were looking at the elevator lobbies, and we were looking at downlights and wall washers. And so all spec grade, we looked at 4 different products. They do have variations in lumen output and wattage of about 40%, but because there's no longer like a 32-watt fluorescent. I mean, it doesn't work that way anymore. So some are 10 watts, some were 14, and somewhere in between. But you know, with dimming, we can compensate. And what we did is ran a calculation, of course, and this is just the rendering. And in case you can't actually see the differences, I've marked it up here, but they weren't exactly the same. And we found that we had a strong preference for 2 of the 4. And why is this? Because now it's not just about bending a reflector and putting an MR16 lamp in there. Now it has to do with what paints they use and what they use to bend the light. Is it silicone or other materials? I mean, I don't even know everything that's out there. There's plastics, there's paint finishes, and everybody does things a little bit differently. Some use, modules that are ready, some develop their own. Another case study on options. So this is a public project, and I think it's really important to talk about public projects, especially, because I've been hearing, anyway. So what this is this is a roundhouse. It's an old rail station, and we did the design about 10 years ago, and it was actually an LD+A. But the center turntable, so it's about 120 feet long, and they like to put trains, old trains there, and people can walk alongside the trains on both sides. And they wanted to highlight these trains at night. So that's what you're looking at here is a mock-up of 3 different manufacturers' fixtures. So we started with 6 manufacturers. It's a reasonable number. We're using a grazer. It's a non-standard application just because of the geometry. So we started with 6 products, but we're in Toronto, and this project is by the lake. And 2 of the manufacturers came back and said, we don't have a -40 driver. So we're down to 4 manufacturers. And if you take a look at the actual performance of these fixtures, we really ended up with 2 that we liked. And with those 2, one used a remote driver, so you could have one driver driving a number of fixtures, versus the other manufacturer that had an integral driver. So every fixture has a driver. There's cost implications to that. The remote driver, we knew we always do our budget pricing as we go, and we knew that the remote driver was going to be about 2/3 of the cost. Now, we had to produce the wiring diagrams and the controls, and they were even different dimming technologies. And we're paid to do a job, fair enough, but we're paid to do it once. So what do? So park that, we're going to come back to it. Another case study, this is it's in Canada anyways, it's a very public project in the sense that it's the Ontario Association of Architects, their headquarters. And the building was built in 1990. And it's time for a renovation, and they are going net zero, and they are making this extremely public. Every report, every meeting, like if you go on their website, you can actually access our daylight studies, because they want to show the public that we can go net zero and that you can do it affordably and that it's worth it. So we're under a lot of scrutiny here, but what I'm going to talk about now are these three rooms, the lounge, the conference, and the meeting room that are, at the front of the building on the road. And we wanted to have some consistency with those spaces, particularly from the view from the outside. So this is what we had to start with. Again, this was built in 1990. This was the, compact fluorescent and halogen is what they had to work with. And we were inspired by a fixture that had come out. This is a couple years ago already. And we really liked this. It was an up-down light. But we wanted to use it in a little bit of a different way. And this was what we came up with. And we approached the manufacturer and said, can you do this? And they came back with, sure, we can do this. And not only could they do it, but they could do it, and we got performance. For those of you that can see, we can get, 350 lux on the work plane. Lots of light, up, down, up and down. And they could also do it within reasonable cost, within the budget of the project. In fact, we liked it so much, we had another small project, we were just working on the desk, that we ordered a quantity of one with a custom radius. Now, it wasn't the price of a troffer, fair enough, but it also met the budget of the project. Okay, so it can be done. And now, if you look on their website, and I can't tell you who, because we're IS, and I don't want to say the names, but now it's actually a product on the website. So continuing on the different options we have now with LED technology, so let's just take a look at a halogen cut sheet. So this is all current stuff pulled from the website. So there's a halogen cut sheet for a downlight, one page. And we have options, we can pick, do we need an IC housing or not? Do you want a lens? A few choices. This is our LED cousin. Same fixture. And now we're looking at 12 pages. I'm not expecting you to read this. It's, of course, for impact. And those are the types of choices we have. So we still have, the stuff on top, the colors and the more aesthetic. But at the bottom, we talk about things like dimming. And that's how much information there is on the different kinds of dimming. So not the same pan. Warm dim, we talk about that. Now that one's only 9 pages, but the options there can almost be even, more twisty in terms of your brain. So lots of options to consider. Again, we go from one sheet to all of this. So we're not dealing as designers with what we used to. Very different scenario. This is that same project where we showed you the elevator lobbies, but this is now the corridors. So just to let you know, this building is in Montreal. It was one of the 2 buildings in the 1960s that was constructed by the Vatican. They actually used to build buildings, so it's unbelievably over-designed. And it was the first co-op building in Canada, which was the precursor to condos. And at the time, each unit was selling for about 10 times the price of a single family dwelling. So it's a fairly high-end type of project. So you can see on the left, that's their existing. It hasn't been touched since 1960. And the interior designer's rendering is on the right. Now, because of the construction of this project, they have services. That's a section through the corridor. They have services running through the corridor. Okay, there's no access there. We were given 3 inches high by 5 inches wide. That's the red there, where we could actually install lighting. Not very much space in there at all. Couldn't go onto the walls, couldn't go into the floors. That's what we had to work with. So, there was that lighting layout for that part of it. And just to let you know, this worked out to 360 feet of floor, so it was about 10,000 linear feet. So it's a lot of lighting. So we did find a nice grazer, very flat, very minimalist, but as you can see in our calculation rendering on the left, we could still see that light source, and that did not make us very happy. But it seemed to be like the only thing we could do. We were then considering valences and whatnot, and at the same time where we were getting a little anxious about that solution, out comes a co-design. And this is a co-design between a ceiling manufacturer and a fixture manufacturer. And there are a few out there now. And what this is, this product, basically, it builds in the cove. So here is your cove as part of the ceiling, and that's your light fixture pointing up. And so the way it works is that the light comes out of the fixture and we shine up to shine down and graze the wall. So this is optics in a new way. And being an engineer, I looked at this and I went, okay, so we're shining up to shine down. We are actually bending light. Okay, physics, this really shouldn't work. And furthermore, the problem was that they were showing a standard detail that was much larger, needed a much larger aperture than we could give them. So we went back to the manufacturer, and they came back with the dimensions that actually worked with our project. But again, the skeptic says, oh, that's really great. So they've just made some CAD adjustments, and they're sending it to me, and they're saying this is really going to work. So we run calculations, and they do as well. And we actually found that according to the calculations, this really should work. Went a step further and built an off-site mock-up. So you'll see it's not quite what we were looking at. And this is just an iPhone photo, so it's not a great photo. But we did find that not only did it work, so no, we didn't get our 28-foot candles on the floor. We could get up to 34 or 340 lux. And we also had fantastic uniformity on the walls. Clearly there's a hot spot at the cove, but the way it lit the walls was just, it really blew me away. And I sat there thinking, like, this really shouldn't work, but it does. It's fantastic. So we are bending light in new ways. So here's where we would do the fill-in for options. So here are the key points. So LED luminaires have allowed for unprecedented freedom in design. The performance of LED luminaires depends on many things, such as the light engine, the driver, and the optics. And there's a wide variety of configurations to achieve this luminaire performance. Modifications and custom are less difficult and certainly more affordable today. But mock-ups and reviewing samples are strongly recommended, more than ever. And finally, the process to specify and design with LED luminaires has added steps, as you can see. So let's talk about lamp life, and I'm not going to go over this. I think most of us are familiar. L70 means 70, this is the time it's going to take for our LED to reach 70% light output, right? And so we can just as easily define it as, the point where it reaches 80% of light output, because it's by definition, this is what lamp life means. But the key here is that LEDs typically, they don't burn out, they don't die, they just fade away. So the question I have is, what is the useful life of the LED? So if it's rated for an L70, which is this point here, what about all that light over all that time? Can we not make use of that? And how do we do that in an effective way? So my argument, first of all, is that the useful life of the LED is how long it can provide adequate light. And we're going to come back to that. Okay, so park that as well. Just going to spend a brief time on lighting controls now with LEDs, although they're important. So the first point is that codes and standards now, there's typically some requirement for some kind of lighting controls in buildings now. I assume that's true in the United States. It's certainly true in Canada. The minute you have a window or a skylight and you're a certain size, you have to start incorporating lighting controls. The other big difference now is that these controls devices, most of them are wireless, or it's very easy to get wireless. So installation costs are much lower. And also, the cost of the devices themselves has dropped quite a bit. And what we're finding, for example, on that project, the residential with the corridors, that the cost of lighting controls is now about 5% of the cost of the luminaires. So once upon a time, lighting controls could be 50% the cost of the luminaires. So now it's becoming almost silly not to do lighting controls. It doesn't make any sense. Now, with controls, there's an issue of compatibility, as you probably have experienced if you've worked with any LEDs and any lighting. And this is just one example from one manufacturer. So I have pulled, this is their compatibility with dimmers with the compact fluorescent and LED lamps. Okay, this one document from one manufacturer, but my point is, it's 80 pages, and it's updated regularly. So it's not something you can learn today and figure you know it. You have to check it every single project, over and over again, and sometimes even between the time from when you specify to the time you get your shop drawings, and you'll see that too. Also with controls, we have an added step. This is from a residential project. The first one I pulled up. We added 2 extra columns here where we say whether the driver is integral or remote, and also the details. So this was, I swear, the first project I pulled and the first page. So this one has 2 inputs of controls. This fixture is ELV, and this one is DMX. Okay? And this is the way it goes. Every fixture can have a different type of control scheme. And you see all those blue squares? This is only part of the floor plan. Those are the proposed locations for all the remote drivers. If any of you do residential, and we do all kinds of projects, but in particular in residential, there is nothing worse than a client who has paid you a ton of money and put in all this effort into their home and then opens a closet to unpack and can't put anything in there because the contractors decided to put all of the drivers in there. So I believe that's our job. Start to finish lighting. We have to think about this all the way through. We try not to leave too many decisions up to the contractor anymore. It's not fair. So, twice before, over the past 50 years, information technology has radically reshaped competition and strategy. And we're now on the brink of a third transformation. Any ideas what that is? So the seminar, other people are going to talk in detail about a lot of these things, so you've got to go to all these other seminars now. But this is IoT, the Internet of Things. And why are we talking about this in lighting? Well, first of all, IoT exists already. There's about 20 billion devices that are estimated in use today. And that in the next 4 years, about 96% of businesses are going to be using the data or some of the information that we have collected from an IoT system. Now, there's great potential for lighting devices because lighting is everywhere and it's already electronic, and it's just been targeted as the perfect kind of product to integrate IoT. So what does IoT do for us? Well, we've always known that sensors can give us occupancy, and tell us, well, this was occupied at this time till this time. But now, if we understand how to use all of the data, in this case study, and when you get your note, I think everybody gets a copy of the presentation, so you'll have the link at the bottom. But this is a terrific video that talks about what they did with the data, and it was able to predict a bottleneck at the loading dock. So suddenly this isn't about lighting anymore. This is actually about productivity. And so this is the way lighting is integrating into business, not just lighting. Furthermore, parking lot, this is one of Canada's, it is Canada's most profitable or the highest sales per area of the mall. This is in Yorkdale Shopping Centre. This was an award-winning design. Only in the lighting business do we get excited about parking lots, right? But, okay. This is luxury items, but parking was a nightmare. There's 250 stores. It's at the, there's two major, highways, lots of traffic, nightmare, close to my house, never wanted to go there. But now with their new lighting, they've integrated IoT in there, and it's updated every 15 minutes. You can go online and decide before you go where you should park. And as you go through, there's red lights and green lights to say, don't bother coming here or don't, okay? So IoT, whether we like it or not, and it's more technology, lighting is becoming more science than art in some cases, but we as consumers, we want this. So IoT is here to stay, and it's just going to expand. So getting back to controls, okay? Getting back to our case study here and our offsite, and these corridors. So we looked at the fixture that inspired co-design. That fixture was rated at an L85, so 85% at 50,000 hours, and the L70 was 100,000 hours, all right? Now keep in mind, this is a corridor, it's operating 24/7. So 100,000 hours is about 12 years, okay? So in 12 years, they're going to have to replace, if we design for the L70, they're going to have to replace all of these LED modules. There's 10,000 linear feet. This is about $1 million worth of product and about $250,000 of replacement parts. So how happy do you think this condo is going to be in 10, 12 years when it gets too dim and they're going to have to do $250,000 in relamping? All right? So how do we deal with that? So again, what about if we don't design to L70? What about if we design to L30 till it gets to 30% and we just dim it because we saw that we can get 30-foot candles on the floor? It's a corridor. The preference was 8-foot candles. So we're going to over-design, and we're going to start with the dimmer setting low, and it was fairly stable to dim, and over time, we're just going to keep increasing the setting. And hopefully, we can expand that lamp life. Maybe we can get it to 20 years, 25 years. Now, this is all theoretical, but this is the best we got right now. So, anybody have a problem with this? Are there any issues that you can see with this? Like, what happens to efficiency way down here, right? Up here, the fixture might be 100 lumens per watt, but down here it's certainly not, right? So we're getting a more and more, or a less and less efficient system. So we're engineers also, we're designers, we're also engineers, we like numbers. And so we did our little calculation and said, okay, if we used a standard output, okay, say we're not going to do any controls at all. So instead of over-designing to 30-foot candles, we'll be fair. We'll just over-design to 15. We'll go with the half output. And that is how many kilowatt hours. If we even tune it further, so just tune the drivers so that we get, say, 11-foot candles and let it sink down to 8 to the L70, right? This is our consumption. But if we put in lighting controls with aux sensors, and what we do is, and we are allowed to do that by code, I don't know if that's true everywhere now, but in many places it is, where you can put occupancy sensors that you go a high-low. So when unoccupied, the corridors go down to 1-foot candle. All right? Well, that's the bottom is what your energy profile looks like. So even though it's getting less efficient, at no time over 20 years do you even achieve the energy consumption. And remember that the cost of controls is 5% of the cost of the fixtures. And this is the cost profile, and just to get to the point, the cost profile, the net present value of adding lighting controls was over $600,000 on $1 million project, or $1 million in lights, and a rate of return of almost 40%. Okay, I'd invest, for sure. All right? So the fill-ins is that for life, instead of lamp life, consider useful life. And that leveraging controls can reduce replacement costs. Now with controls, LED drivers are inherently dimmable. Wireless controls are reliable and inexpensive. It's critical to coordinate lighting controls luminaire by luminaire. And integrating technology can provide many experiential advantages, but it does add layers of design and coordination. All right, so we're going to start wrapping this all up. So another case study, this is retail. And we were responsible for about 100,000 square feet of the public spaces in the mall. And for various reasons, the biggest challenge on this one is it's an existing mall built in the 1970s, and there's an office tower above it. So, today malls tend to have these grand, high ceilings. This doesn't, and this is what it's competing with. So they wanted to try and raise the ceiling, and after various negotiations, anyhow, we ended up with this kind of a concept. And that was the fixture that we selected. You'll notice it's got a concave lens, and it has a very nice wide distribution that allowed us actually to place fixtures about 20 feet on center and still get a nice even spread, and has great color. And the architect just loved the way it gave you that ethereal look, that it almost looked like you can stick your hand up into the fixture. Now, are there similar fixtures? Absolutely, yes, there are. But either they did not pass the performance or the aesthetic that the performance that we were looking at, or the aesthetic that the architect wanted. So we ended up with a one-name spec. We also used multiples on this, and because of this kind of articulation, this 120 degrees where it doesn't really clip too much, sometimes you get the multiples and you aim it and half the light is clipped by the edge. This is a really great performer, and we couldn't find anything. And again, we were trying to spread them further out. Remember, public spaces, you want the retail to shine. People should be walking through comfortably and feeling like it's bright, but it should be, the stores that are drawing them in. So we ended up with a one-name spec on that product as well. Okay, now remember, this is also about $1 million worth of product. So, come along, shop drawings. So what happens? From the time we specify to the time we get the shop drawings, they change modules. And now instead of a 26-watt module, okay, so there's a 3-degree difference in the beam spread, but we're now up to a 38-watt module. So that's really different. So suddenly we had to, especially because we convinced the owner, we did all this vetting of the product, can't just let it go. So we have to go through and spend another 3-4 hours on a new product. More time. Now, not complaining, because this same manufacturer, just to let you know, we had a problem where the 9-inch depth, there was suddenly this eco duct, this honkin' duct was running right across 5 fixtures, okay, just 5. And we needed to get this fixture to about a 4-inch depth. And within 48 hours, we had a remote driver, they had sent us their shop drawing, and just, they made it work for us. And they even gave us a warranty. And it was $150 per fixture, so the whole thing cost an extra $750. Okay? Where we have, this is the same, these are the office entries to the Shepherd Center, same product. And so you notice that this is the one where they don't meet at right angles, they come off, and so you're going to have custom angles in there. And when we get this shop drawing, this was the first pass of the shop drawings. And so we had, I think it was something like 60 runs of this stuff. And so we got a catalog page, not even a cut sheet, a catalog page saying 22 feet, 17 feet, and they just submitted that 60 times. So that was a major rejection. That is just not enough information for a contractor to come up with 600 feet of this product and know what to do with it, right? So we were much more looking for something like this. Now shop drawings, particularly when you're customizing, so this is a note to the manufacturers and the agents. This is the kind of stuff we're now looking for. A cut sheet is not good enough. We need to be able to show them these custom angles. We also need to be able to show the contractor how much product goes on each driver. There are limits. Think about how much time it takes us to figure out how to use these products. And again, we're throwing it at the contractor who's never seen it before, right? How many times they, oh no, there's a lighting consultant, now I'm not using my usual stuff. It's so hard, right? We can't leave it to them. It's not fair, it's not realistic. It's not going to get built the way we want it, and it's not going to work if that's what we do. This is just an example, again, for shop drawings. So this project was done a little while ago. That was just the concept. And this is what the manufacturer did when it came to shop drawings. So they were showing even different whip lengths and, you know, where the drivers were going. Sometimes it takes this kind of, you know, creative approach just to get it right. So finally, with legacy technology, we had 3 phases of involvement for the most part, as we talked about. And now I'm going to argue, we said mock-ups and samples really important, but because we do more daylighting, and it is becoming more popular as well, even in Canada, right? You don't need direct sunlight, you just need light, natural light, that we need to get involved earlier in the phase, in the process, get in with the architectural concept phase so we can help them with orientation and massing and do all those kinds of things. And also to get in on budgeting. I don't know how many of you are familiar with this. This is the McLeamy curve. This is the HOK. They came up with this. And what this means is that the earlier on in a project timeline, if you get involved early, then the cost to the project is low. And the later you make changes, you know, the higher it is. But what this says to me as a consultant is that the earlier that we are involved in a project, the more likely it is that what we design is actually going to get built. So we need to get involved earlier. And so that our design now, our involvement and our design process now, it's kind of the same, it's just bigger, and it does take more to do what we're doing. Our fees have certainly gone up. I have to now allocate more time for shop drawings, etc., right, from what we've talked about. And the process. So does this change much? Well, we have been accused of, you know, being control freaks. I'm sorry, my stuff is not, should be flashing at you, but anyway. So we have been accused of being control freaks. Okay? But what this has done is given the contractor a process that looks like this. There's no more or equal. In many cases, you're getting a one-name spec. And it means that this is what you buy. And when you have 4 weeks, you know what the contractors think? This is awesome. I can worry about something else. Okay? But the question is, what about competition? How can you have a single name spec, especially on public projects? How do you do that, right? My question is, how do you not do that? Because sometimes we just can't come up with the third name, or the second name even. But let's take a look at this. Public project, what happened here? So remember we had 2 products that we could use, remote driver, which was cheaper, integral driver, more expensive. So we designed it with the least expensive product that would work. Big note saying, contractors, you can use this other product, you can quote it and bid it, but you're going to have to, as part of your submission, you're going to have to design the controls, submit it to us to check. Okay, we don't like to do that. So what happens? And we do go back, and we try to close the loop, because it's great, in our heads we think of all these things and it's so terrific. But in reality, does it really work? So we go back to the contractor, this is almost done now, and said, so how was it when you were bidding it? He said, it was fine. He said, we got the two prices, one was more expensive, we left it alone. Duh, right? So we did have more than one name. And it still worked, and it runs really smoothly. And what about on this one? This one was even more interesting. This one, they did a pre-tender cost, they called it GMP costing, gross maximum price. It's an exercise. They're about 70% through the design phase, and they give it to a contractor. They say, give us a GMP price, and, and commit to it, and we'll give you the job now. I don't know, sometimes these pricing exercises, I just want to shoot myself. Because we were 95% complete, and they came back with a budget for lighting that was actually double, $2 million instead of $1 million. And I looked at them, and it's our little design firm of 4 people, and we're looking at, the big majors and saying, sorry guys, your pricing is wrong, something's going on somewhere. And I'm thinking, okay, I'm a contractor, you're giving me a project that you think is 70%, or that you're telling me is 70% complete. You're darn right that and you're asking me to commit to a number, you're darn right I'm gonna put lots of padding in there. And I'm pretty sure that's what's going on. Anyway, so how do we deal with this now? Now we're stuck. So we convinced the owner. We did something that is just totally, I don't know of anyone that had done this, and I think it worked out well. We did a tender to the manufacturers and the agents, and we said, okay, here's the specs, here's the drawings. We need you to commit to a price, and we need you to hold that price and bring it in through distribution over the next 2 years. Okay, sounds wonky, right? Our numbers came in 17% under budget. Okay, we were in the high 800s instead of $2 million. We are a year and a half into construction. We still have not hit the $1 million mark, even though it's a renovation, and then there's been what happens, there's all kinds of changes, and things don't fit and you have to redo things, and then they write change orders and try and get more money. And we're still good. We're still on budget. And again, contractors, how was it when you had to work with this? When we just gave you a cash allowance that you can draw on, and as far as the guys on site are concerned, they're good. They said it makes their bidding a lot easier. Can you imagine with all this controls coordination now to be issuing a performance spec for controls? And in that 4-week tender time, to expect a contractor to get it right, get it cheap, and then build it to our satisfaction? Really? It doesn't work anymore. It does not work anymore. So the final fill-ins, and then we're done, is that aesthetically similar luminaires can have very different performance. It's often difficult to find equals today. Competition is still possible with a single name specification. And lighting design is now part of creating the experience. So I haven't even begun talking about things like, video mapping, where, this is not working. So sorry, this is a lovely video that starts to show you the video mapping, and it shows you that as you're driving down the street, you can have an IoT, the IoT system is picking up your phone and says, oh, Deb was at a movie last week, and she's coming to this stoplight. And as she arrives, on the building becomes an ad for a movie. What's stopping that, right? That's where we are today with technology. So lighting today is about creating the experience. It's exciting, but it's also much more complex than it ever has been. Now, I find it hard to answer clients' questions today, as you've heard with all this explanation. It's sometimes hard to answer with a simple yes or no. So the trick is that at the back of the fill-in sheet that none of you have, but you will have it in your package because it's, you know, the way you get your, I think we get a little, do we get a jump drive where you can download this stuff? But the fill-in sheet is part of the downloads. Or if you want, I'll leave my cards, you can, I'll email them to you. But on the back page, I actually summarize for the LED technology of where we stand today, so that you actually have the summary of it. So LEDs have changed the paradigm of the lighting industry. We must reconstruct our approach to suit. Imagine on your next project you don't ask, what do you want your lighting to be, but just what do you want? It can be done, and it can be done on budget. Thank you. So how do we do this now? Do you want people that want the tour? If there's any questions. So if you need to go, please go. If you have questions or you want to stay, please go. But go ahead.
Well, I'm just wondering, have you taken into account red list free items in the lighting? Have you seen any, you know, inroads, like, for example, Google's portico standards or anything like that?
Are you talking about POE fixtures?
No. I guess the red list free, basically, chemical, you know, passive chemical free lighting fixtures. Okay.
No. Sorry, that's a simple answer. Come on. Yes, I do. Sorry.
You know, there's California is probably bigger than most of them.
Yeah, Title 24, right? They lead the way for all of us, so.
Red list free is like all the